Okay, students, today we will discuss the electrochemical cell. The first part of electrochemistry, it is electrochemical cell. Here I have drawn a Daniell cell. It is also a type of electrochemical cell. You see here in this Daniell cell, this is anode compartment, this is cathode compartment. Here zinc rod is dipped in zinc sulfate solution, and in the cathode compartment copper rod is dipped in copper sulfate solution. Okay, now both of the half cells are joined by a salt bridge. This is a salt bridge, and the rods are joined externally by an external wire through a voltmeter. Okay, now when this cell, that is salt bridge, inserted inside the two half cells and it work, okay, the connection is complete. What do you find? You find here some current flows there. Okay, now indicated by the voltmeter. The electrons are produced in the zinc electrode, flows from the zinc electrode to that is copper electrode, and the copper ions from the solution will be reduced here. Now whatever the mechanism takes place, I am explaining here in the board. You see the zinc rod, okay, zinc solid gives the electron forming zinc 2 plus ions, leaving behind the electrons. Okay, here you see the electrons are left behind the zinc electrode. Okay, zinc atom goes into solution in the form of zinc ions. These are zinc ions, positive charge ions are zinc ions, and these are the electrons. Okay, these electrons produced are transferred from this zinc electrode to copper electrode. Okay, now I will toward the end of my discussion I will tell you why it is zinc rod that produces the electrons and why the copper ions get reduced. Okay, now here this reaction is called oxidation reaction. Zinc gives Zn2 plus 2 electron, and cathode the copper ion in the solution get reduced by taking the electrons given by zinc electrode, and which are transferred through the external wire to the zinc electrode. So copper ion gains 2 electrons forming copper solid. The overall reaction is this one. Okay, now here, so let us write down another one. Copper 2 plus 2 electron gives copper solid. The overall reaction is Zn solid plus Cu2 plus gives Zn2 plus Cu solid. Okay, now here oxidation and reduction both takes place. Oxidation and reduction takes place, so it is a complete redox reaction, and electrons are produced as well as consumed. So this electrochemical cell now produces energy which we can use in our day-to-day life. Okay, this is called electrochemical cell, which converts chemical energy into electrical energy. Now how can you represent this big electrochemical cell? It is represented by simply, this half is called anode half or anode compartment. This is called cathode compartment. Zinc electrode is called anode compartment, and the copper electrode is called cathode compartment. So according to IPSC nomenclature, okay, the half cells, the anode always represented at the left hand side and cathode is represented at the right hand side. So zinc solid slash zinc 2 plus ion double slash copper 2 plus ions and copper solids. The single slash indicate boundary separation. Zinc rod solid, it is separated by aqueous solution of zinc sulfate. So there is a boundary line, and both the similarly copper rod is dipped in copper sulfate, so there is a boundary line, and there are two parallel lines indicate the presence of salt bridge here. Salt bridge is the U tube which consisting of inert electrolytes which can join these two half cells, therefore complete the circuit. And second is it maintains the electrical neutrality. By completing circuit, it allows the current to flow, and therefore you can draw electricity. Now then we'll discuss how can you represent this cell. This representation cell is there. Now I can represent once again zinc solid slash Zn2 plus aqueous salt bridge Cu2 plus aqueous slash Cu solid. This is called anode compartment, anode, and this is called cathode compartment, cathode. Remember, in the electrochemical cell, while representing, the cathode is always present at right hand side and anode is always present in the left hand side. And the potential of the cell is about 1.10 volt. Okay, the E cell is about 1.10 volt. Now this can be calculated by applying the formula. You see, calculation of half cell. Now, before going to half cell, I would like to tell you what do you mean by electrode potential. Okay? Then our topic is to discuss what is called electrode potential. Now see, in every electrode here, zinc rod is separated by zinc sulfate. There is a potential difference set up between zinc electrode and zinc sulfate solution. It is negative charge zinc electrode and the solution is having higher positive charge. The potential difference arising between the electrode and the electrolyte is called electrode potential. In case of zinc electrode, it is called oxidation potential. In case of copper electrode, it is called reduction potential, as reduction takes place in copper electrode. Now, all the potentials are as per the IUPAC nomenclature. Again, all the electrode potentials are expressed in terms of their standard reduction potentials or reduction potentials. Now, when the concentration of all the species present in the solution, in the salt bridge or in the solution, particularly in the electrochemical cell, are 1 m, then the potential is said to be standard electrode potential. Now, all the potentials are measured in terms of standard electrode potentials. Here, I have been given here a chart of standard electrode potentials. Now, we'll discuss then what is the utility of understanding the standard electrode potentials. Now, see, let us consider that Zn2 plus 2 electron gives Zn here E naught is equal to minus 0.76 volt. Copper 2 plus 2 electron gives copper E naught is equal to plus 0.34 volt. Now see that zinc ion has a standard electrode potential of minus 0.76 volt. Copper ions have the standard electrode potentials of plus 0.34 volt. It means the ion which has higher reduction potential, that will be reduced faster as per law. What do you see? Then out of zinc ion and copper ion, the copper ion will be reduced faster because it has higher standard electrode potential. Now reverse the statement. Okay, reverse the statement. What do you find if you ask that which one will be easily oxidized? So it will be zinc that will be easily oxidized in comparison to copper. So zinc to give zinc 2 plus ions and 2 electrons, but copper will not be oxidized. Therefore, out of zinc and copper, it is zinc which will be oxidized faster because it has a negative value of standard reduction potential. As I told you in the beginning that I will tell you why zinc electrode is taken as anode and why copper electrode taken as cathode. If you replace copper rod from this side, put here, and zinc this side, you will not find any reaction to take place. Okay, because zinc is more reactive. Now, so zinc always acts as a anode and cathode always acts as cathode. Next we will discuss the importance of standard electrode potential. Okay, now so first of all, calculate standard electrode potential. Standard electrode potential of a cell is represented by E naught cell is equal to E naught cathode minus E naught anode. Here in this case, cathode is copper electrode, so E naught Cu2, E naught you can say right minus E naught left. Okay, the electrodes are already present that the anode is at left hand side and cathode is at right hand side. So E naught cathode minus E naught anode means E naught right minus E naught left. So here E naught right means E naught Cu2 plus by Cu minus E naught Zn2 plus by Zn is equal to 0.34 volt minus 0.76 volt is equal to 0.34 plus 0.76 is equal to 1.10 volt. That means the cell works. Now if E naught cell is greater than 0, it indicates that the cell works. That means we can produce current or electricity from the cell. If E naught cell is less than 0, we can say that the cell will not work. Okay, so for a feasibility of a cell, E naught cell should be greater than 0. Now, so student, we come to know the standard electrode potential. Again, here we will then analyze what is the meaning of negative value of standard electrode potentials. You see that zinc has negative minus 0.76 volt, whereas copper has plus 0.34 volt. So it is zinc in comparison to copper will be oxidized. So any substance which gets oxidized is reducing agent. Okay, and any substance which get reduced is oxidizing agent. So out of zinc and copper, if you compare, zinc will be oxidized faster. Okay, so it is reducing agent, and copper is reduced faster, copper ion, so it is oxidizing agent. That means the one which have more and more negative standard reduction potentials are more reducing agents. So lithium, lithium is the strongest reducing agent in this world. Okay, and lithium, there are three factors which govern the reducing character of an element. Number one is enthalpy of sublimation, second is enthalpy of ionization, and third is enthalpy of hydration. In class 11, you know that the enthalpy of hydration enthalpy of Li plus ion is the highest, because very high, because of very small charge. Okay, small size and high charge density. Now this is all about the standard electrode potentials. Okay, so negative value means more reducing agent and positive value means more oxidizing agent. Now we will discuss here that with question number 1. Okay, predict that the following cell will work or not, feasible or not. Cell is, let us take CR/CRT plus PB2 plus PB. Okay, now see, so here it is anode. Okay, here is cathode. Now E naught cell is equal to E naught cathode minus E naught anode. So what is cathode? PB2 plus. Here PB2 plus is minus 0.13 volt. So minus 0.13 volt minus what is for chromium? For chromium it is minus 0.74 volt, minus 0.74 volt. So it will be equal to minus 0.13 plus 0.74 is equal to plus 0.61 volt. It means again it is positive. So this cell also works. Okay. Now in this way you can calculate predict whether any cell will work or not. Next we'll discuss how can we represent an electrochemical cell if a cell reaction is given. Okay. Now let us take that the following cell reaction takes place, for which represent the cell. The reaction is Mg plus 2Ag plus gives Mg2 plus 2Ag. Okay. Now if such a question is given, then our first task is to see the oxidation half and reduction half equations occurring in the cell. You see, magnesium is at zero oxidation state, goes to plus 2. So from 0 to plus 2 means what happens? Increase in oxidation number, that is oxidation. And for silver, from plus 1 to 0, that is decrease in oxidation number. What happens there? Reduction. Okay, reduction means cathode, oxidation means anode. So we can say the cell is represented as Mg slash Mg2 plus short bridge Ag plus slash Ag. Okay, so now students, you come to know how can you represent an electrochemical cell. Second, how can you predict the electrochemical cell, predict whether the cell works or not. And also we come to know that values or what is the meaning of negative value of standard electrode potentials. More negative value of standard electrode potential means higher the reducing agent. Okay, and for a cell to work, we can say that if the standard EMF of the cathode is more than anode, then the cell will work. And next, one more thing I will tell you, that in this case, if it is connected to an external source, okay, here you can connect it to an external source with a battery. Okay, now if it connected to a battery more than the potential of the EMF of this cell, that is 1.10 volt. In the Daniel cell, if E external is greater than 1.10 volt, then in that case the reaction will reverse. Whole reaction will change. Okay, that means that there will be in the earlier case, in Daniel cell, electrons are produced at the anode. They are transferred from the zinc electrode to copper electrode. So current flows from copper to zinc. Now in this case, if external potential is given, Then the reaction reverse means copper here, from copper electron are produced or you can be transferred to zinc, and reduction takes place at zinc, zinc 2 plus 2 zinc, and oxidation takes place at copper electron. Or okay, this reaction takes place in the case of electrolysis. Now if E external is equal to E 1.10 volt, you know both the forces opposite each other, it produces 1.10 volt. Some outside battery gives 1.10 volt. There will be no work done by the cell. And third one is, if E external is less than 1.10 volt, then again this cell goes on producing the electricity. Okay, this is all about today for the today's class, and the next class we will discuss how to find out the EMF of a cell. Thank you.